Okay, ladies and gentlemen, let's start talking about improper integrals. Now, the first thing we need to talk about improper integrals is remember that when we're finding an integral, we're finding the area under a curve. Now, we've found nice, pretty areas under curves previously. No problem finding the area under this curve. We have a couple things going on for us. First of all, it is continuous. Second of all, there are no cusps. There are no infinite discontinuities, none of that kind of thing, no asymptotes. So this integral, not too shabby, no big deal. If we have something like this, we can also find the area under this curve, even though it technically causes us a problem with our integrals, because with a cusp right here, what I have to do is break this integral into two pieces, and I have to do one integral over here, and I have to do one integral over here, and then I simply add the two areas together. So we've already dealt with some light improper integrals. What we're going to deal with now is something significantly more complex. We're going to deal with something that looks like this, where they have blows up in the middle, we have one that blows up to the right, and we have one that blows up to the left. Now, the other problem is this only deals with this point here or this point here on the right and on the left. But what if we take the exact same graphs, but I wanted to find the area from here, some value b, and I want to go back to negative infinity. Okay, well, since I don't have this issue, that's a separate problem. I'm not even dealing with that. This looks like I might potentially be able to find the area under the curve, but now we have a different problem. We have a bound that goes from negative infinity to b. That's going to be a problem we're going to have to deal with. Up here, again, let's take the exact same graph, but instead of dealing with this, let's forget that. Let's start at a and go to positive infinity. Again, this looks like it has some potential to have an integral. But now our integral is from a to infinity of f of x. And so this causes us a problem. Well, in all of these cases, the answer to our prayers is limits. In this case, we're going to take the limit as x approaches b, but it approaches from the left. And in this case, we want to take the limit as x approaches a, but now from the right. Here, we're going to be using the limit as b approaches negative infinity. Okay. And, I'm sorry, as x approaches negative infinity. And over here, we're going to take the limit as x approaches positive infinity. So we're going to use limits to solve some of our various issues. Now there's more improper integrals than that, but let's start there. Now I will tell you I am using the examples right out of the book, so you can follow along there if you wish. Now, the first thing that we have to deal with is we have to deal with this guy. Now our clear problem here is that we are not continuous. And so by not being continuous, I cannot just integrate this using the power rule saying negative x to the negative first, bounded at negative 1 and 2. That does not work because it does not qualify for our continuity rules. So if we are discontinuous, we can't take the integral. That makes it therefore improper. Well, instead of dealing with all this at once, let's just deal with basically what amounts to half of it. So that's where we're going to here. Now, it is a different equation, but it has the same basic behavior. You would think, well, wait a minute, that's going to positive infinity. I already have some question marks about that. But let's see if we can come up with a good solution on this. Now, first things first, I have no trouble with the 0 at the bottom because it has a clearly defined place. It is clearly right there. Now, the problem I have is when I get to 1. So I don't really want to go to 1. I want to go to R or T or F or Q or whatever it happens to be, some other letter. Now, in this case, we're going to say the limit of the integral as R approaches whatever it is that I'm talking about. In our case, it's 1, and it's coming from the left. So, using this information, we can go ahead and integrate this. And we can go ahead and integrate like we're used to. And it turns into negative out front. And because, well, here, let's show all the work here. We have 1 minus x raised to the negative 1/2. So if I'm going to go ahead and do this, I'm going to say, well, it's going to end up being a positive 1/2. So that means I need to bring a 2 out front. But it's going to be this thing raised to the positive 1/2. That's the outer function. Now the inner function is 1 minus x. So if u equals 1 minus x, du equals negative dx. And so that's where this negative comes from out front. And that is found at 0 and r. The problem is I can't get to r. I'm going to have to use the limit. So the limit as r approaches 1 from the left of negative 2, parenthesis 1 minus x, the quantity 1/2, found at 0 and r. So if I go ahead and plug all this in, I come up with the limit as r approaches 1 from the left of negative 2, parenthesis 1 minus r raised to the 1/2 minus negative 2, parenthesis 1 minus 0 raised to the 1/2. All right, with all that, I can clearly see that this here is going to be 1. The square root of 1 is 1. I end up with a positive 2 here. So the question becomes, what's going on here? Well, if I'm approaching 1, 1 minus 1 is 0. The square root of 0 is 0, so negative 2 times 0, so I have 0 plus 2, so my answer is 2. Now you say, well, wait a minute, you took the limit of the first piece, but you didn't take the limit of the second piece. On the contrary, I did take the limit of the second piece. It's just that there are no r's in this component, so it's just like if I split limit as r approaches 1 from the left of this problem, negative 2, 1 minus r to the 1/2 minus the limit as r approaches 1 from the left of negative 2, parenthesis 1 minus 0 to the 1/2. It's just with no r's here, this limit has no function, and so it has no purpose, not no function, it has no purpose. And so that's why this simply becomes a constant 2, whereas this turns into 0 equaling 2. That is your basic process. We're simply going to replace the problematic part with some sort of limit. That's what we're going to be doing, replacing the bad part with some sort of limit. Okay, we'll pick it up in the next piece.